Hello. In this video, I'm going to give a demo of this collab, which is activation function collab. And let's go ahead and see what are the steps that I have run as a part of this collab. In this first cell, we install and import all the necessary libraries like PyTorch, NumPy, and Matplotlib. And the output simply confirms that libraries have been loaded successfully without any errors. So next part is these are all the problem with linear equation, and it says why this matters for deep learning and everything. Let's go to next code cell. Here we set up a visualization to demonstrate the XOR problem, showing why linear models fail. So the output, if we see all these data set like Moore's data set, circle data set, and everything, and if we go to the output displays three plots as we can see here, emphasizing that single straight that line cannot separate the XOR data points. So we can see this is the circle data set, this is the Moore's data set, and this is the XOR problem. Next in this next block, yeah, in this block, the implementation is that mathematical formula for the classical sigmoid and tanh activation function along with their derivatives. And if we go to the output, the generated graph shows the S shape of these functions, illustrating the vanishing gradient problem where gradient become too small. These are all tan h derivatives and this. Next, we define the rectified linear unit function and its derivative, then plot them to visualize how they work. And the output is clear. Output clearly shows ReLU output 0 for negative inputs, linear growth for positive ones, explaining how it's revolutionized deep learning. Next, here we implement some popular variant of ReLU, such as a leaky ReLU and ILU and CELU, and to solve the dying ReLU problem. This is the whole leaky ReLU, ILU, and this is the table visualization part. If we see the plots, these variants behave for negative values, ensuring gradients keep flowing during training. Next, we dive into modern activation function like GELU and Swish and Mish, which are widely used in advanced models like transformers. The output chart compares these smooth curves against the standard ReLU and highlighting their continuous gradient. Next is this code visualize how activation function like sigmoid are used at the output layer for binary classification task. And if we see the outputs, the bar chart output shows how logits are squashed into probability between 0 and 1 with a threshold of 0.5. This is a table, output activation by task table, which we can see the respective values. Then we create a toy moons data set and then train a flexible neural network using different activation function to compare their performance. The output prints the final accuracy of each activation function, with most of them achieving around 97.98% accuracy, while sigmoid struggles at 87%. Next, finally, we plot the training loss curves and decision boundaries for all the activation function we tested. The resulting visuals which we see here grid lets us compare how smoothly and effectively each activation function separates the moon shaped data set. We can see here. And These are all the quick reference post on, and that's it with this collab. Thank you.